Now I'm about to work example 2 from page 196 in your textbook. Example 2 on page 196 in the textbook. This is what it says. Water pours into a fish tank at a rate of 0.3 meters cubed per minute. How fast is the water level rising if the base of the tank is a rectangle of dimensions 2 by 3 meters? So this problem is dealing with water being poured into a tank. Now this rectangular tank has a base of dimensions 2 and 3 meters, but what's really important for you to notice whenever you read this problem is that it says water is poured into the fish tank at a rate. So what we're about to get is a rate. And it says that it is a rate of 0.3 meters cubed per minute. Now when you see meters cubed, that is a clue to you that we're in a third dimension. Okay, so you measure distance in one dimension. You know there's just one aspect to a distance, is a straight line. When you measure area, you measure it in two dimensions because there is both a length and a width. So distance is a straight line. When you measure area, it has a length and a width to it. But when you measure volume, there's a length and a width, but then there's also a height that comes into play with a volume. So you're adding a third dimension here whenever you start dealing with volume, right? So when you see that this meters cubed per minute, that meters cubed is your clue that what you're talking about right now is a volume, and it's a rate. So this is a change in volume with respect to time. Now we were given the dimensions of the bottom as 2 and 3. So I'm going to call the bottom dimensions a length. I'm going to call the length 2 and a width, and I'm just going to call the width 3. Now hopefully you can tell from the fact that we have a dV/dt, this volume right here, that the formula that we're going to be using is for the volume of a rectangular prism, which is length times width times height. Length times width times height. In this problem, the length and the width are both given at 2 and 3. That's the dimensions of the bottom of this rectangular tank. Now, it then goes on to say that water is pouring in at 0.3 meters cubed per minute. How fast is the water level rising? So if you think about a tank, if you just had a tank here, and imagine that this was a three-dimensional tank. Okay, so let me try to draw a little contrast to the back here. Just make myself a cube. Okay, I'm going to connect these and this. And this will be behind and then there. Right? And if you imagine that the water began to pour in the tank, what it would do is it would begin to fill the tank up. Okay? So it would fill the tank up and it would begin to rise and rise and rise. And so the water level is actually going to be moving up the tank. So there will be a change in height of the water with respect to time, and that's actually what this problem is asking us for, right? But if you notice, these two things on the bottom, the length and the width, are not going to change. The length is going to continually stay 2. As this thing rises, the length from one of these lines to the other just stays 2 the whole time. And the width to get from one side to the other of the front of this thing stays 3 the entire time. So that means that the change in length with respect to time is 0, and the change in width with respect to time is 0. And that's good news, because if you remember, whenever these things are 0, we can go ahead and plug these numbers that we're given into the function before we start to take a derivative. So volume is equal to length, which is 2, times width, which is 3, times height. So volume is equal to 6h in this case. The volume of the amount of water that tank is holding at any given time, in this case, is 6 times whatever the height of the water is. Now, in order to get our rates involved, dV dt, and then what we're actually looking for, dH dt, we need to take a derivative. Well, the derivative of the volume with respect to time, using implicit differentiation, will be change in volume with respect to time. And 6h with respect to time is going to be 6 times dH dt. dV dt was given to us from the very beginning, so we can take this 0.3 and plug it in for dV dt. And now to get dH dt by itself, we only need to divide by 6 on both sides. So if you take 0.3 and divide it by 6, you will get that the change in height with respect to time is 0.05. And our units here are important, okay? We were doing meters. It was meters, so there's meters per minute was our measurement for time. So the water level is rising at 0.05 meters per minute.